Hello friend, good morning. So in today's video we will see the relationship between various pressures like gauge pressure, absolute pressure, atmospheric pressure and vacuum pressure. So there will be some questions in which we will be given that the gauge pressure at this point is this, and at some points it will be given in vacuum pressure, or there will be given that absolute pressure at this point is this value. So you have to know what is the difference between absolute pressure, gauge pressure, atmospheric pressure and vacuum pressure. So we will see these relationships first, then we will solve a numerical question based on this. Okay, so first of all, what is the relationship between these pressures? So see, absolute pressure is pressure measured from zero pressure, where there is no pressure. Like if you go to space and there is no pressure, from that point pressure measured is absolute pressure. See, the absolute pressure is here, it is measured from 0 point. When there is no pressure, from there it is measured as absolute pressure. So this is absolute pressure total and from measured from 0. So what is atmospheric pressure? Atmospheric pressure is pressure which is on earth due to our atmosphere. So this is a point on earth, and this is air above the surface. So there will be some pressure which is rho gh, P is equal to rho gh, due to this height or column of air above our head or above the ground on the surface of the earth. So this pressure which is applied due to column of air on the surface of earth is atmospheric pressure. So this is, if you calculate the atmospheric pressure, scientists have measured it, it is around 760 mm of mercury, or it is also called 1 bar or 1 atmospheric pressure. Then what is the gauge pressure? So we know that at all the points on earth atmospheric pressure is almost same, so we take that point atmospheric pressure as reference. So the pressure measured from atmospheric pressure, so this is atmospheric pressure. So it is easy to measure pressure from here, because absolute pressure we cannot measure where atmospheric pressure is already available. So at the point, suppose you want to measure the pressure, then you will get that pressure in terms of gauge pressure. So if you will put a gauge and measure the pressure, then you will get gauge pressure. So in case of gauge pressure, atmospheric pressure is considered 0, and this is taken as reference. So from there, here if you measure the pressure, then it will be gauge pressure. So what will be the vacuum pressure? Suppose at point there is vacuum, means pressure is less than the atmospheric pressure. So vacuum pressure will be equal to pre-atmospheric pressure. Total atmospheric pressure is this, and from this, suppose this is suppose 750 mm pressure due to atmosphere, and suppose 300 mm of mercury pressure is less than this atmospheric pressure. Suppose at point pressure is 760 minus 300, 460 mm of mercury. Okay, so this is called 300 will be called vacuum pressure, because this shows the how much vacuum is there. So absolute pressure at that point will be 460 mm of mercury, but vacuum pressure will be atmospheric pressure minus vacuum this column 300. So vacuum pressure will be this 300. P atmospheric minus P absolute. Okay, so what will be the relationship between this? So for gauge pressure, P atmosphere is considered 0, because at earth at all point there will be P atmospheric pressure. If it is not controlled externally, then there will be atmospheric pressure at all the points. So we consider it at 0, and from this point, this is taken as reference point. From this point, with what pressure we measure is called gauge pressure. So P gauge pressure, you can see here, it is above the atmospheric pressure. Here it is 0, and from this pressure, gauge pressure is measured. So what is vacuum pressure? So vacuum pressure is the pressure which is less than the atmospheric pressure. So suppose as we see, 760 is approximately 760 mm of mercury column is atmospheric pressure. So suppose at a point at absolute pressure is 400. From this point pressure is 400 mm of Hg from absolute pressure 0 point. So total mercury column at atmosphere is 760 and at this point only is 400. So what is vacuum pressure? So this is vacuum pressure. So what will be vacuum pressure here? 760 minus 400. So what is the difference in the P atmosphere and absolute pressure? That is vacuum pressure, which is less than atmospheric pressure. So it will be 360. This is the vacuum pressure. So what will be the relationship between these three? First of all, let's see. This is absolute pressure. So P absolute is equal to, see here, P atmospheric, this one plus this one. This is gas pressure. So it will be equal to P atmospheric pressure plus P gas pressure. This is one relationship you can remember. And another relationship is vacuum pressure. P vacuum is equal to this pressure. This pressure is difference between this one minus this one. So it will be P atmosphere minus P absolute. But remember, vacuum pressure will be always less than the atmospheric pressure. If pressure is more than the atmospheric pressure, then it will become gauge pressure. So P vacuum is P atmospheric minus P absolute. So now based on these relationships, let's solve a problem, a numerical problem. What are the gauge and absolute pressure? So we have to find gauge pressure and P absolute pressure at 0.3 meter below the free surface of liquid. So this is liquid free surface. We have to find P here. Suppose this is a point. The depth of this point is 3 meter from the open surface. And density of liquid is given as 1.53 into 10 to the power 3 kg per meter cube. If the atmospheric pressure is equivalent to 50 mm of Hg. So P atmosphere here is given as 750 mm of Hg or mercury, which is equal to divided by 1000. If we convert in meter, 0.75 meter of Hg mercury. The specific gravity of mercury is 13.6. Specific gravity of mercury is 13.6 and water density of water is 1000 kg per meter cube. So as you know that specific gravity is ratio of density of liquid, reference liquid, here it is mercury, divided by density of water, because water is the reference here. So it will be equal to 13.6 will be equal to density of mercury is, we have to find density of mercury divided by density of water is 1000. So from here density of mercury will be 1000 into 13.6 will be 13,600 kg per meter cube. Okay, this is density of mercury. So what will be the atmospheric pressure? It is equivalent to 750 or 0.75 meter of mercury. So suppose this is column of mercury and this is 0.75 meter. So this is equivalent to this. So if here is pressure 0, then here is P atmosphere due to the weight of this mercury. So what will be the weight pressure due to weight column of this mercury? Rho GH, as we all know, P is equal to rho GH. So what will be the density of mercury? 13,600 kg per meter cube, into acceleration due to gravity is 9.81 and height of this mercury is 0.75 meter. Okay, so if you will calculate this, then you will get 100,062 Newton per meter square. So this will be atmospheric pressure. So we have to find the gauge pressure. So gauge pressure is atmospheric. If we consider atmospheric pressure as 0, then gauge pressure is measured from atmospheric pressure, which is reference level. So gauge P gauge is due to at this liquid there will be atmospheric pressure acting, but we will consider it as 0. So we will consider pressure only due to this 3 meter of fluid. Pressure is rho GH, which is equal to, what is the density of fluid? 1.53 into 10 to the power 3 into G is 9.81 into height of column is 3. Okay, so if you will calculate it, then you will get 45028 Newton per meter square. So this is gauge pressure, because we have not considered atmospheric pressure. So what will be the absolute pressure? So P absolute is P atmosphere plus pressure due to gauge pressure. So P absolute will be equal to 10, atmospheric pressure is 100,062 plus this one 45028. So if you will add these two, you will get 145090. This is absolute pressure at this point. Okay, so I hope you understand now relationship between absolute pressure, gauge pressure and vacuum pressure. So if you understood this problem, please like our video. Thanks for watching this video.